Hello, we are going to look at more level 1 science today, focusing on the 2018 acids and bases paper. Again, we are going to go through the entire examination paper today. So let's get started. Question 1. The diagram shows models of 3 different atoms. We got lithium, sodium, and fluorine. Use the diagram to answer parts A, B, and C. So why are lithium, sodium in the same group and periodic table but in different rows? So what it means by being the same group, like say for lithium is here, sodium is here, potassium is here, and then you have hydrogen sort of kind of over here. We can, which is normally hanging out and so on, because hydrogen is not a metal but it behaves like a metal, but that's not really relevant to this particular question. So if you look at the lithium's electron arrangement, this is 2-1. Sodium's electron arrangement is 2-8-1. I mean, if you just count the number of electrons in the shells, first shell is 2, 8, 1, etc, 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 you can see that they are. And then if you look on the periodic table, I'll get rid of the hydrogen because it's in the way, they are all in the first group. So what the first group actually means is that all of these elements in this first group, they are all what we call group 1 elements. And what group 1 elements have in common? What do they have in common? They all have 1 valence electron, which is that 2-1, 2-8-1. Potassium is 2-8-8-1. They always have 1 valence electron because, that's what in the same group actually means. But 2-1, which is electron arrangement for lithium, as you can see, there are 2 numbers. So this means this is in the second period because it has 2 electron shells. 2-8-1, this is in the third period because it has 3 electron shells. So that's why they are in different rows, because they have different number of electron shells, and that's all there is. Okay, so atoms have the same number of valence electron, which determines the group, and then period is determined by the number of electron shells. Lithium has 2 and sodium has 3. I mean, you can just use a periodic table to figure this out on the spot. You shouldn't need to panic for a question like this. This is a merit question anyway. All right, let's look at B. Sodium and fluorine, so let's just remember the electron arrangement. This is 2-8-8-1 and fluorine is 2-8-7. They both form ions, have the same electron arrangement. How can they form ions? But they have different charges, so you should refer. This is important. Number of protons, charge, electron arrangement of the 2 atoms and ions. Now I'm not going to rewrite the whole answers here, but this is something I did for a couple of my videos. Remember, for sodium is, sodium's not 2-8-8-1, that's potassium. Sodium is 2-8-1 because sodium has 11 electrons on the periodic table. You should be able to find it. What does that mean? What are you writing with? You're writing with a pen, aren't you? Protons, electrons, neutrons. We don't care about neutrons. Let's just get rid of the N, so it's now Pe. So how many protons do we have? 11. It's the same number as the atomic number. So this is what you find on the periodic table. How many electrons do I have? 11. So what does that mean? 11 electrons I can rearrange to electron arrangement of 2-8-1. And ask yourself, is this a full shell? Is the outer shell full? No. What is it going to do? It's going to lose 1 electron to have a full outer shell. And then it's going to be 2-8. How many electrons do I have now? I have 10 electrons. And okay, how many protons do I have? I still have 11 protons because I don't gain or lose protons. You only gain and lose electrons. So what does that mean? I have 11 protons, 11 protons, 10 electrons. I have 1 more proton than electron. P plus means positive protons, E minus means negative electrons. Hence the charge is an A+. Now again, I've shown this for kind of twice now on different other videos. So because remember, we want you to refer the number of protons. I did right here. The charge I did right here, +1. Electron arrangement of the atoms and ions, So do it this way. It helps you tick all the boxes, and you can just follow up with a bit of explanation, but all the key things that we look for are already here. Now for fluorine's 9, so same thing. This has 9 protons, 9 electrons. It's going to be 2-7. It's not full. It's going to gain 1 electron to have a full outer shell to be stable. Therefore it's going to be 2-8 I have 10 electrons, 9 protons. I have one more electron than proton. Therefore, the charge is, hence the charge is -1. Okay, let's have a look at the answers. So as you can see, this is I already got all this information out there, so I don't need to say it. But this part you do need to write. You must write this. They need to gain or lose electrons to have a full outer shell to become stable. This line that I highlighted and circled and starred, please memorize it. You are looking at one achieved tick right here. Okay, so just memorize it. When they say ions formation, chuck that sentence in. Okay, they need to gain or lose electron to have a full outer shell to become stable. Write it in. Okay, so then the rest are already covered. They have the same electron arrangement of 2, 8, but then they're different number of protons and the charges are different. Blah 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 blah. Okay, very straightforward. Next one, magnesium fluoride has a formula of MgF2. Explain how the ratio, so it's a ratio equation, is linked to the charge of the ions. In the answer, what do we need? Include the number of electrons gained and lost by each atom as it forms the ionic compound. So you need to look at Mg as an element, and then you need to look at fluorine as an element. So on the table of ions, you should be able to see Mg2 plus and F minus. So that can be really helpful here. So Mg is going to lose 2 electrons, because 2 plus means you lost 2 negatives. That's why you're positive. One way that I've managed to get someone to memorize it before is that, think about in life in general, if you lose some negative, don't you feel positive? So if you 2 plus, that means you lost some negative, so you lost 2 electrons. If you're 2 positive, that means you lost 2 negatives. Okay, so it lost 2 negatives electrons, hence the charge is +2. Okay, fluorine comparison, this need to gain 1 electron. Now the charge is -1. So magnesium need to lose 2, but then fluorine can only gain 1. Therefore, we need 2 fluorine atoms to gain a total of 2 electrons from 1 magnesium atom. Okay, therefore, and then when you combine them together, the charge is Mg2F. So you have 1 Mg per 2 fluorines. Okay, so this is bullet point number 1. You talk about the charge, you talk about the electrons. The other thing linked to the charge. Okay, so Mg is 2 plus, fluorine is 1 minus. If they were to form ions, this is a 2 plus charge, this is a 1 minus charge. When they combine together to form an ionic compound, it needs to be neutral. That means the overall charge is going to be 0. That's +2, that's -1. That's why I need another negative to give me a total of -2, which cancels out the +2. So in order to cancel the charges, we need 2 F's to give us a -2 charge. Okay, so let's have a look at the answers. Magnesium loses 2 electrons, this one gains 1. So as Mg reacts, it loses 2 electrons, which is gained by 2 fluorine atoms. Okay, now to have a neutral compound, 1 magnesium ions need to cancel out the charge of 2 fluoride ions, so just to balance the charges. Okay, so that's the end of question 1. Let's move on to question 2. Now, if you see this type of reaction thing for acids and bases, the only type of reaction that you learned in year 11 science in acids and bases is neutralization. I know some schools do precipitation, decomposition, displacement, all that sort of stuff. That's a different standard. Read the standard name. I get sick of seeing precipitation or all sorts of crazy names, irrelevant reactions. In this particular paper, look at the title of your paper. It says acids and bases. That's the only reaction we accept, which is neutralization. This is the only reaction we teach you in the standard, which is neutralization. Even if you say acid and base, we will give you achieved. You only need 8 achieves to pass, guys. I mean, if you get 9 achieves, you're guaranteed 4 credits. Don't make silly mistakes. All right, next one. Word equation. So you got KOH, H2SO4. So if you have potassium, now if you're going for merit and excellence, I wouldn't even bother writing this, but it's actually a good habit to do this from scratch. If I just put them together, this is an acid hydroxide is a base, and I did this in my previous video as well. Just remember, or oxide or hydroxide, they're all bases. Carbonate are bases as well. So acid plus base gives you salt. So how do we figure out the salt? It is the remainder of the metal, which is potassium, combined with the leftover sulfuric acid, which is the sulfate, and then plus water. Achieved. How do we get merit? Potassium hydroxide is KOH, sulfuric acid is H2SO4, and then what do they become? They become potassium sulfate. Potassium is K plus, sulfate is SO4 2 minus. That's 1 plus, that's 2 minus. I need another plus to balance the charge. That's 2 pluses all together, so it's 2 Ks and 1 SO4. Don't delete these numbers at the bottom, okay? They have nothing to do with the charge. Keep them with the whole thing. What is water? That's H2O. Now if you've done that, you got a merit. Now next step, balance. Need to go for the excellence. The thing I always tell my guys to do is don't look at the O's and H's first. Look at the unique atoms. Look at the sulfur. That's one, so I don't need to touch it. Look at the K. That's 1K, that's 2K. Put the 2 in front. And then once you've done that, can you see I've changed the number of oxygen and hydrogen? Now we can look at the hydrogen. Can you see that's 2 hydrogens I just highlighted? There's 2 hydrogens here, so that's 4 hydrogens on the left hand side. I want to have 2 hydrogens on the right hand side. Put a big 2 in front of that, and then your numbers should be fine. So if you attempt to balance it but got it wrong, you still get a merit, assuming that you did everything else correctly. So your base, like these things that I'm just highlighting right now, these need to be written perfectly for a merit. Right, moving on. A solution of potassium hydroxide is placed in a beaker. Universal indicates, oh my lord, this type of question. So explain what happens to the color while the sulfuric acid is being acid until no more color changes are seen. Okay, so you are literally going from, let's just do it this way. Let's find it like this. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12. Oh. Don't you hate it when you get too excited with the scales at the beginning of the chart, and then you run out of space. All right, so at 7, so these are the colors. I'm going to put the universal indicator colors on top. At 7, this is green, this is neutral. When it's neutral, the H year 11, so just H plus signs equals the OH minus signs. Okay, and one way you can remember, just remember the color of rainbows. All right, you should know this from year 9: red, orange, and yellow. So it's Roy, G, Biv. So I normally do 8 to 11 as blue, and then 12 to 14 as purple. So these are your, so just your rainbow colors without the violet and everything. We just combine them together with your blue and purple. So these are your universal indicator colors. Okay, and then for your concentration. So when you have 1 and 2, you have a lot of H plus signs. When you have 3 and 4, you have more H plus signs, but less compared to what you had before. 5 and 6, you still have more H plus signs, but only a little bit more. But when you turn into a base, let's say from 8 to 11, you have a lot more OH minus signs compared to your H plus signs. And then your 12 and 14, you have a lot of OH minus signs compared to your H plus signs. If you are going for the achieved, spend 5 minutes, memorize what I just draw. When you see a question like this in the exam, like the coloring of pH changes, color changes, whatnot, put that in your question. If you have absolutely no idea what to do, if you did it like this, you would have got 3 or 4 achieved ticks just by doing that. And how many would you need to pass? 8 or 9. So in this case, you're already halfway there. Okay, so but if you're going for excellence, we want you to understand what does it mean. So right at the beginning, I mean, we kind of did it here. You're starting with purple. So we want you to go through this color change. We want you to mention, you want to start with purple. The pH is 12 to 14. It's a strong base. I have a lot of OH minus compared to H plus. Want to add some some of the acid is going to start neutralizing. I'm going to lose some of the H plus ions. I'm still going to have more OH minus compared to H plus, so the pH is going to be 8 to 11. And then when it becomes green, that's because the H plus and OH minus are equal, and I made neutral salt and water are produced. I mean, you make salt and water along here anyway, but you know, this is not really great chemistry, year 11s. But you know, we're looking for this evidence here at pH 7. And then if you keep adding acid, you're going to have more H plus compared to OH minus. The pH is going to be 5 and 6 when it's yellow. You just mention all the colors and link to the pHs and link to the H plus and the OH minus concentration, and then you'll be fine. Okay, so you can, you know, read all this. This, like, I love using diagrams for these. The picture speaks 1,000 words. Honestly, if you just put that in, it covers, well, that's not enough on its own. You can support it with a bit of written paragraph like these, but everything we need, the basic things, are already there. Okay, let's move on to question 3. We're tracking through it quite nicely. So what sort of question do we have here? So magnesium carbonate powder, dilute nitric acid. Okay, so these are the two solutions we have. We have not solutions, 2 chemicals, magnesium carbonate. Oh man, I hate doing word equation. If your science teacher didn't tell you already, scientists are the laziest people on the planet. Like, that's why we come up with all the symbols, symbol equations, abbreviations, because we hate writing wordy things. Okay, so this is nitric acid, acid plus carbonate. When you have acid plus carbonate, you're always going to make carbon dioxide, because where would your carbon go? It's going to go somewhere. So you're going to make carbon dioxide, you're going to make water, and you are going to make the salt. So that's going to be the leftover of the base. So just put the magnesium in front. Nitric acid becomes nitrate. Sulfuric acid becomes sulfate. Hydrochloric acid becomes chloride. Combine them together, and this is your achieve. Balance symbol equation: magnesium carbonate, magnesium carbonate, magnesium is Mg2 plus, carbonate is CO3 minus, so they cancel out perfectly. MgCO3. Nitric acid, memorize it, is HNO3. Magnesium nitrate, Mg is 2 plus, NO3 is 1 minus. Doesn't look very neat. As you can see, this is 2 plus, this is 1 minus. We need another minus to give us a positive, a negative 2 charge, which cancels a positive 2 charge. That's why it's MgNO3 because you need 2 NO3s like I have right here. But then you can't have, you have to put the brackets, otherwise it will be MgNO32, and that looks awfully wrong. And one way they can remember is that we need 2 lots of this, so that has to be in brackets because there are 2 capital letters inside the bracket. Just remember that. Carbon dioxide, CO2, water is H2O. Just on another side note that wasn't covered here, if you have a metal plus acid, this is irrelevant to this question. You make salt and hydrogen gas, yeah? And please, guys, for the love of God, hydrogen gas is H2, okay? Not just H. It's such a shame seeing you getting that wrong. Now, come back to this question. If you balance it like this, you have got a merit, but then you need to do this to get the excellence. Look at how many Mg we have, that's 1. Look at how many Mgs we have, that's 1. But then look at the NO3. Can you see I have 2 lots of NO3? So I have 1 lot of NO3. I put a big 2 in front. Now I have 2 lots of NO3 on the left and on the right hand side. Let's look at the H's because I put a 2 there. So that's 2 H's. That's 2 H's. Everything's happy. This is excellence. Now, moving on. So we mix them together. We're going to make some CO2 gas. Why does the mass of the flask decrease during the reaction? As you can see, as time goes along, the mass decreases. Okay, why does it do that? Because you're losing CO2 gas. The gas is leaving, so you will get lighter, obviously, because the gas will just evaporate. Okay, now what's happening in section A, B, C of the graph? Link your answer to the race reaction and particle collision. So this is very typical question. Let's just break into 3 sections. This is A, this is B, this is C. Yeah, they've already done that, haven't they? So in A, this is where you have the most collisions per unit time. Why is that? This is the steepest part of the graph. Steepest part of the graph, so that means the gradient is the gradient is going to be the most. It's a little bit weird because normally we do it like this, and now they did it other way because they're trying to show you, they're trying to see if you understand, because you're losing, as the faster, think about this, the faster you react, the quicker you lose the CO2. So they're just showing you, look at how steep this is. This is just telling you that I'm losing the CO2 really quick. That suggests a really high rate of reaction. So part A is, why does part A have the most collision per unit time? Because you have the largest concentration. You have the most, you have the highest number of reactant particles available to react, and that's why they're going to easily bump into each other and then results in a higher rate of reaction. And what happened to B is that this will slow down because you're slowly losing the reactant particles. They already reacted. It's less likely for the remaining particles to collide, and when you get to C, there's no more reaction because the line is flat. Okay, so when they collide successfully, they produce products. In this case, as the reaction progresses, the number of reactant particles decreases because you're running out of the ingredient. The frequency, or you can say the number of successful collisions per unit time, decreases, leading to a slower rate of reaction. So in A, there are more reactant particles, more collisions per second. That means you make more particles, that means more gas, more CO2, so they escape, and that's why the mass decreases the most, because you're losing a lot of the products because of one of them is a gas. Now, because there are fewer reactant particles, fewer collision per unit time, look at the per second, that's really important. And then for part C, the reaction has stopped. Okay, now last question. Explain how increasing temperature makes a reaction. I already done this for my previous video. I'm just going to do it really quick. Increasing temperature. It's the same question every single year. Increasing temperature, that means more kinetic energy. More kinetic energy. Particles have more kinetic energy. What does that mean? They will move around more. They will move around more. They will collide more often. They will collide more often. Therefore, more collisions per unit time. Per unit time. Now, because they have more kinetic energy, and because there are more collisions per unit time, a higher proportion of these collisions, will collide, because they're colliding with more energy, will collide with sufficient amount of energy to overcome the activation energy, or just to become successful. Okay, so that means more effective collision per unit time. Per unit time, and therefore higher rate of reaction. Okay, so let's just have a look. Here it is. As the temperature increases, particles move faster, more kinetic energy, more collision per unit second. Blah, blah, due to higher speed, they have more of these collisions will have enough energy. You know, it's essentially what I wrote. Okay, so I do hope this video is helpful enough. I think it's just the physics one, the mechanics one that I haven't done. So yeah, I'll try to finish that tomorrow and study hard, and I'll see you guys next time. Bye bye.